Assalamualaikum everyone. Welcome to the last video for May June 2020 paper 1 2, and I'm sorry for the delay once again that happened between this video and its previous part. It's just because I had been really busy on my finals. But the good thing is they're finished so I can help you guys out. So without further ado, let's begin. So, question number 31. Scientists are trying to synthesize a new element with proton number 119. The element is predicted to be in group 1 element in period 8. So that's kind of the last period of the periodic table. So, I think it's francium at the very bottom. And so you're talking about this is 7, and then you're talking about an element even below that. So they're saying which predictions are likely to be correct about this element. So it says, first part, the outermost occupied orbital of one atom of this element will be an s orbital. So what do you think? Will it be an s orbital? Well, if it's in group 1, it doesn't really matter in which period it belongs to. It will definitely have the configuration of S1. That's why we have the S block, P block, and D block, and F block in the periodic table. So group 1 will definitely have all of its elements will have their outermost occupied orbital as the s orbital. Not question number 2, but the second statement. The atomic radius will be the largest of the 7 elements in group 1. We know as we move down the group, the radius increases, right? Because the number of shells increase. So 2 is correct as well. Then it says it will have a greater first ionization energy than element 118. So here's the thing, what will element 118 be? So element 118 would be, it would be a noble gas in period 7, and then in period 8 right here we have our group 1. We know that when we move down the group, right, and especially when if you swap your period number and you're moving down, what happens is that your ionization energy drops. So 3 is incorrect. You see that in the case for helium and lithium, right? So helium is kind of at the very top, right? And suddenly you see a drop from helium to lithium. Same exact thing happens here. So 3 becomes wrong, and therefore if 1 and 2 are correct, then let me remember the options. Yeah, so the answer would be B. Yep, that's 1 and 2. All right, let's move on. So 32. Which reactions would have the reaction profiles shown? Many people get confused with these reaction profiles. What I suggest them to do is make up a dotted line like this, and then basically draw the arrow which always goes from the reactant to the products, which is in this case this. And if it turns out to go up in the positive direction, then it would be endothermic, and if it ends up going into the downward direction, it would be negative and therefore exothermic. So you must know that bond breaking reactions are basically endothermic in nature. If you look at the first part or the first equation, it is of neutralization in which a base is reacting with an acid, forming a salt and water. Neutralization reactions, remember, are always exothermic. So neutralization reactions are always exothermic in nature. So one can't be the answer. And if you eliminate one in such questions, then the only option remaining is C, which is basically 2 and 3, right? And if you look at 2, it says what's happening is decomposition. A group 2 carbonate is being decomposed. 2 is correct. It is bond breaking, and bond breaking, it's kind of solely bond breaking, more or less. So it would be endothermic, and here we again see dissociation. And wherever you see pure dissociation, remember they're going to be endothermic. So 2 and 3 is the answer, so it's C. It's question number 33. Which factors can lead to an increase in the rate of a reaction? So the first part, a lower activation energy. Well, some people might actually get confused with this one, so I'm going to come to this later on. The second part, an increase in temperature. Definitely, temperature increases, rate increases. Then third is an increase in the concentration of a reactant. We know if the concentration of the reactant increases, the rate increases. In one of my previous videos, I also showed this. I showed this table that you could memorize in order to solve any question that is related to rate and equilibrium increasing or decreasing. So if you see here, we know temperature and rate have a direct relation, concentration and rate have a direct relation. So 2 and 3 are correct. Now the confusion is about question number one. Sorry, not I don't know why I keep repeating question number one, but the first statement, a lower activation energy. Well, here's the thing. If you look at the table, we don't explicitly say anywhere that a lower activation energy will increase the rate. But what do you see? You see catalyst, right? Catalyst is one reason for the rate to increase. If you add in a catalyst, the rate increases. Now ask yourself this. What does a catalyst do? A catalyst lowers the activation energy by providing an alternative path for the reaction. So in other words, what you do by adding a catalyst is basically lowering the activation energy. So yes, lowering the activation energy does lead to a increase in rate. So one has to be correct, and therefore the answer is A. All right, let's move on. Question number 34. Sodium and fluorine are both reactive elements. Two atoms are described. So here's fluorine, here's sodium. Their atomic number, nuclear number is given. They say which statements about these two atoms and the ions they can form are correct. Statement 1. One Na atom has two more protons than one fluoride ion. So we're comparing a sodium atom with a fluoride ion. So a sodium atom has, according to the atomic number, it has 11 protons. And a fluoride ion, now this is the interesting part. I hope you don't make the silly mistake of actually doing this. Oh, it's F minus, so this will become 10, so 1 is wrong. No. Please remember, charges have nothing to do with the proton number. For any given element, its proton number never changes, or else its identity changes. So, fluoride ion has the same number of protons as its atom, and its atom has 9, so the difference is of 2, and therefore statement 1 is correct. Statement 2. One sodium atom has two more neutrons than one fluorine atom. So sodium atom has how many? 12, right? Because 23 minus 11 is 12. And a fluorine atom, because we're comparing a fluorine atom, the difference is of what? 19 minus 9, that gives you 10. So yes, sodium atom does have two more neutrons than one fluorine atom. 3. One sodium ion has the same number of electrons as one fluoride ion. Well, sodium has 11 electrons when it's neutral, and Na plus would have 10 electrons. Whereas a fluoride ion has 9 electrons, and by adding one more to it, it will have 10 electrons. So yes, statement 3 is correct as well, and therefore the answer would be A. Okay, let's move on. Question number 34. In the atmosphere, which transformations can involve sulfur dioxide as either a reagent or a catalyst? So we're talking about sulfur dioxide. So one thing that you note about the reactions, all of these statements and reactions given, is that we see all of them involve one thing, and that is a transfer of oxygen. So either oxygen is being lost or oxygen is being gained. Now here is a common sense question. You have sulfur dioxide, right? Sulfur dioxide loves to get, it loves to get oxidized into what? Into sulfur trioxide, right? Right? So sulfur dioxide loves to get transferred or transformed into sulfur trioxide. So to do that, and this is a reaction that you study a lot in O levels and A levels, and basically for this oxidation we need one oxygen atom, right? So that means sulfur dioxide prefers to get oxidized. That is, it prefers to snatch away an oxygen. If you look at the reactions given, there's only one reaction in which the oxygen is being lost or is being snatched away from the molecule, and that is statement 1. So NO2 goes to NO. So that means sulfur dioxide can actually take away that oxygen and it can convert this to NO. So 1 is correct because It says reagent or a catalyst. Catalysts remain unchanged at the end of the reaction. So if it was only catalyst, then even one would have been wrong because the catalyst must remain unchanged chemically. So, but in this case, that's why they explicitly said catalyst or a reagent. So it can definitely act as a reagent, snatch away that oxygen and give you NO. So one is correct, but in 2 and 3, if you note, they are gaining in oxygen. And sulfur dioxide, as I said, it prefers to get oxidized. It's very difficult to take away an oxygen from it. It's more easy to give it an oxygen. So 2 and 3 can't happen. And if 1 is the only the correct option, then D is the right answer. Okay, I hope that makes sense. Let's move on. Question number 36. The bond P of the HBr molecule is Q than that of HI molecule. So, which pair of words correctly compare the above sentence? Okay, so the first one, the bond energy of the HBr molecule is greater than that of HI molecule. Well, I hope that you know that the only difference in these molecules is of the halogen or the halide that is attached. And we know that as we move down the group, the size increases. And if the size of the atom increases, the size of the orbitals increase. And when the size of the orbital increases, then the overlap that they have with other orbitals, it becomes less effective, so the bond gets weaker. So statement 1 is correct. The bond energy of HBr molecule is greater than that of HI molecule, and that's something you can confirm with the data booklet as well. The second statement says the bond length of the HBr molecule is less than that of the HI molecule. Remember one thing, bond energy is inversely proportional to your bond length, okay? You can either remember it like this. Okay, my pen, like always, is doing some issues. But yes, the bond energy is inversely proportional to bond length. Remember this. So according to that, well, I don't know what's wrong with me. Maybe I'm high on sleep, but yeah. So if the energy is greater, the length has to be less. And in other words, you can also memorize this in this way that in the HBr molecule, the Br is larger in size, and if Br is larger in size than iodide, my bad. I'm going crazy, perhaps. Sorry, my bad. If Br is smaller in size than iodine, which it is, then in that case, it will overlap more effectively with hydrogen's 1s, and they will be much closer together because of the smaller size of the orbital. So, therefore, 2 is correct because Br has a smaller size than iodine or the halides. And looking at the third statement, finally, so the bond polarity of the HBr molecule is greater than that of HI molecule. So what do you think about that? We know that as we move down the group, our electronegativity decreases, right? And in the halogens, we have Br at the top and then we have iodine, right? So this means iodine is less electronegative than bromine. And if it is less electronegative than bromine, then the HI bond has less polarity and the HBr bond has more polarity. So 3 is correct. The HBr molecule does have greater polarity. And if 1, 2, and 3 are correct, the answer is A. Let's move on. Compound X has the structure shown. Which statements about the compound X are correct? I just love organic chemistry. I don't know why, but I just love it. And I am kind of planning to have a organic chemistry quick sessions with O level lads, but let's see about that. Looking at this compound X, we can see that this is a C double bond, which is a carbonyl, and in this case, it's a ketone because it is attached with carbon on one side and carbon on another side. So this is a ketone. Okay, so let's clear that up. We know that this is a ketone. And the other one, if you note, is an alcohol, right? Because there's a carbon and OH is attached to a carbon, so that's correct. But which kind of a alcohol is it? It's kind of very important to always note that down. And if you note here, this carbon is not attached to any hydrogen, but rather it is attached to 3 carbons. And if that is the case, then this alcohol is a tertiary alcohol, right? So now let's look at the options. X will decolorize cold acidified KMNF4. Okay, there are actually two problems with this statement. Statement 1, first of all, ketone will not get oxidized. That's the purpose of KMnO4, oxidation. So ketone will not get oxidized, right? So we can forget about that. Looking at the tertiary alcohol, you should know that acidified KMnO4, which is actually an oxidative agent, it again cannot oxidize a tertiary alcohol because tertiary alcohols don't get oxidized. The reason being that there's no hydrogen attached to a carbon, which can potentially get oxidized. And therefore, the statement 1 is incorrect. But alongside that, if you note this said cold, remember that even for the oxidation of alcohols, you should have hot acidified KMnO4. Okay, that's a preferable condition. So 1 is incorrect, and if 1 is out of the game, then the answer has to be 2 and 3 because that's the only option without 1. And so the answer is C, but let's look at 2 and 3 nonetheless. X gives an orange precipitate with 2,4 NPH reagent. It would because it has a ketone, right? So 2 is correct. X does not react with Tollens reagent. Now, Tollens reagent, if you remember, is used to differentiate between an aldehyde and a ketone. The reason being that ketones don't get further oxidized, but aldehydes do get further oxidized into carboxylic acids. So it's true that this compound X will not react with Tollens reagent because it's a ketone, and ketones do not react with Tollens reagent. They do not get further oxidized. So this statement is correct as well, and so the answer is C, confirmed. Let's move on. Question number 38. Propanol reacts with hydrogen cyanide. Which absorptions are present in the infrared spectrum of the product? Well, first of all, remember for your AS, the only spectroscopy that you have in syllabus is infrared spectroscopy. And infrared spectroscopy is basically used to identify the functional groups in a molecule. Okay? Now let's look at the reaction that's happening. So you have propanol, which I'm going to summarize this as C2H5. And then you basically have, because it's propanol, it's an aldehyde. This is a structure, a kind of a condensed structure. And then you have HCN, and HCN we know gets dissociated into H positive and cyanide ion. And this cyanide ion, there's a lone pair on carbon. There's also a lone pair on nitrogen, but it's actually carbon, which actually, well, the molecule kind of um, does this, but like it's actually the lone pair of carbon which gets donated. So this attacks over here, right? And this bond actually breaks heterolytically. What this is nucleophilic addition, and what this results in is C2H5. This becomes CO negative, and this becomes CN, making the entire the opening the structure up, and this H plus that we had initially, because the cyanide has been used here, this H plus gets attached here, and we get OH. All right, this oxygen basically donates its lone pair to H plus. So what functional groups do you see here? Because that's what infrared spectroscopy does. It identifies the functional groups for you. I see in nitrile, I see a COH bond, and I also see a CO bond, right? And we also see, because I've condensed this, but we also see CH bonds, right? So on the next slide, I've actually added in the table as it is given for the infrared spectroscopy in your data booklet. And according to it, let's look at first statement. It says a weak absorption in the range 2200 to 2250. So 2200 to 2250, which is weak, is for the nitrile. So statement 1 is correct because we do see a nitrile here. It says a strong absorption in the range 3200 to 3600. 3200 to 3600 is right here. And this is strong, and this is for a H bonded alcohol. So don't you see an H bonded alcohol here? The OH bond, we do see it, right? So this is also correct. Looking at the third option, a strong absorption in the range 1040 and 1300. So 1040 and 1300 is right here, and it is supposed to be strong for alcohols, ethers, esters for this CO bond. Do we have a CO bond? Yes, we do. It's kind of messy, but you know that we do have a CO bond right here, right? So even statement 3 is correct, and that results in the answer A. Two important things to pay attention to. Don't only just pay attention to these. You're lucky if you didn't focus on these and you got this right, because well, in this scenario they didn't trick you by this. But you know, for infrared spectroscopy, if you have such an MCQ, don't only focus on the range given, but also on the kind of absorption given, because they could have simply said it's a weak absorption and then this answer would have been wrong, because we can see it's strong, right? So it can't be weak. So therefore, pay attention to that as well. Moving on. Okay, question number 39. Which alcohols cannot be dehydrated to form alkenes? Now that's kind of weird, because we classify alcohols in primary, secondary, tertiary, and we never talk about any alcohol not being dehydrated. That's something that usually teachers don't tell, but I love telling my students about this, because this does come in MCQs just as how we did right now. The thing is, the alcohol that cannot be dehydrated is the one which has a single carbon. As simple as that. It's as simple as that. An alcohol with a single carbon in it cannot be dehydrated to an alkene. The reason being that the phenomena of dehydration works in this way. So the carbon onto which the OH is attached, this OH gets removed, and it is only on the adjacent carbon, be it here or be it here or on both sides, it's only on the adjacent carbon of which the hydrogen is removed. And from here we form water. Okay, so you need an adjacent carbon with a hydrogen. So in this scenario, and with single hydrogen, add in the fact that you should have is hydrogen attached to it as well. So looking at statement 1, we have CH3OH. It's methanol. Is there any other carbon? No. So statement 1 is wrong. And if statement 1 is wrong, then 2 and 3 are bound to be correct, because the only option without 1 is C. Well, let's look at 2 and 3. 2 has a carbon. It's a tertiary alcohol, but it does have a carbon next to a carbon with a hydrogen, right? So 2 can actually undergo dehydration. And this cross actually is a tick and this is a cross, because it's talking about cannot. And in this case, again, you have a carbon and alongside it has carbons with hydrogen. So this can also undergo dehydration. So cannot is false here. So that's why the answer should be C. Now let's go to the last question. Question number 40. A reaction mechanism is shown. Which statements about this reaction are correct? Well, many people who would be giving the entire A levels together, they might confuse this with benzene, but be careful. There is no circle inside. There's no delocalization. There is no double bond. This is actually a cycloalkane. So it's kind of it's a cycloalkane, but it's a more like a cyclohaloalkane, because it has bromine attached to it as well. Well, let's look at the reaction. You don't need, don't get, in organic, don't get overwhelmed by the structures. The concepts are the same as long as you know them. You can actually have even a 50 carbon organic compound and you will easily be able to solve the question. So it looks scary, but it looks fun as well. Don't worry. It says, which statements about this reaction are correct? 1. Heterolytic bond fission occurs. Remember, the only homolytic bond fission that we do have in in our organic that we get to see is during the free radical substitution of alkanes. And nonetheless, if you look over here, what's happening? We see a bond breaking, that is the CBr bond, and we see an ion being formed. It is only in heterolytic fission that ions are formed. In homolytic fission, radicals are formed. So as a ion is formed because of the CBr bond breaking, it means that it is a heterolytic bond fission. The second statement says it is a substitution reaction. Well, don't you think so? Look here, a bromine, right, got replaced with a hydroxyl group or a hydroxide. Well, it was substitution, right? Addition would have been if over here the bromine had not been replaced and it was still here, right? Then in that scenario, it would have been addition. But in this case, one basically atom has been replaced by a group. So whenever one thing is replaced by another in a chemical reaction, we say substitution has occurred. So 2 is correct as well. The third statement says that OH behaves as an electrophile. Okay, phile, remember, means loving. Okay, so electrophile means electron loving. Simple rule to remember for anyone who gets confused with nucleophile and electrophile, remember this thing. We want what we do not have. It is as simple as that, to be honest. We want what we don't have. So anything that is loving electrons or negativity would have too much positivity with it, right? And anything, or and also vice versa, because anything that has too much negativity with it would want something positive, or it would love something positive. What is hydroxide? Don't forget about the mechanism. Just look at hydroxide, okay? What is hydroxide? Hydroxide is this. Hydroxide is negative. And if it is negative itself, what does it not have? Positivity, right? So it is not behaving as an electrophile, it is behaving as a nucleophile. Because if it is negative itself, it's going to run after positivity, and that is nucleophile. Loving nucleo being positivity. So three is incorrect, and therefore one and B is the answer is B. I think B option is one and two. And moreover, I can also explain this in this way that if you look at the CBr bond, because carbon is attached to a more electronegative element, it will become partially positive and bromine will become partially negative. So if hydroxide is attacking a partial positive being or partial positive substance, then that means it's acting as a nucleophile. It wants that positivity. So that's it for today, guys. I try to keep this video especially summarized and condensed because I know that you don't really have the stamina of actually watching and going through a 40 or 50 minutes video, especially if it's only covering 10 MCQs. So I hope this video helped you. If it did, give it a thumbs up. Leave a comment down below if you have anything specific you want me to do, and do not forget to subscribe and hit the bell icon. Moreover, because it's my vacations, I will try my best to cover as much content and as many past papers as I can for both A levels and O levels. And well, till then, I will then see you. Okay, Khuda Hafiz.